Anybody run one bar stats? Yeah, you guys are trained well. Close, damn close. And it's arguable how tall I actually am anyway. So 71.5 would be what I always, people ask me how tall I am. I never hit 6 foot with the hair, yes. But I've never hit 6 foot to the top of my skull. So you guys, pretty close on average, even with the outlier in there, very nice. Oh, I just called it an outlier, I wonder if it is. I just called that 67 an outlier. I wonder if it is.
Looks like it is.
Looks like it is. It's definitely different. And it's definitely the lowest data point. And now what we're about to do is some non-mathematical analysis of that low data point. Non-mathematical, completely non-mathematical. So here's a quick histogram of the data. All I did was I hit zoom 9. So if you do zoom 9, you guys look just like that. Now you might notice if you hit zoom 9, David's like, wait a minute, that looks kind of weird. You're right, because this bar in the middle is too tall because it's actually combining, I think, the 6 and the 12 together. And remember what the TI does. It decides what window it wants to be in. That's why I go back and start finagling. I like to mess with the windows and make them a little more logical. So that's where I press my window button. Its X-min is set at 67, which I love. Its X-max is set at 76.33, which I don't know why it did that. I made that 76. Why not 75? Anybody remember the answer to that? Why did I make it 75?
Because there's a number in there. So.
The problem is we do have one person. Ron, it was you. You voted 75 inches. Watch what happens if I make it 75 and I make the X scale 1. So what this is going to do is every bar is going to be 1 inch. So the first one's going to be the 67 and the 68 and the 69. But if I just press graph now, I'm missing Veronica's vote. There's the 67, 68, 69, 70, 71, 72, 73, 74. She's over here. And the reason for that is because the TI kind of sucks at graphing statistics. It loves graphing. It does a very good job of graphing continuous data, because this bar, the TI doesn't think of this bar as just 67. It thinks of it as everything between 67 and up to but not including 68. So that when you actually press trace on it, it's going to say that. The min is 67, the max is less than 68, which means it's only counting that 167, but it has to be convinced to do it in this way. So that's why you'll always, I shouldn't say always, you'll usually see me bumping up the X max by 1 more unit to make sure we catch that largest data value. And then when you press graph, there's Veronica. There she is out there on the right side. Now that, of course, when you trace over to it, boom. When you trace over to it, the frequency of 1 says min 75, max less than 76. So it's counting everything in that range. There's only one thing in that range. Veronica's 75. Cool? It's just one of those things you have to kind of bridge the gap between continuous and discrete. Excellent. So here's a question I have for us. Should we talk about the average with this data? Do you think it's bell-shaped enough? Let's see hands. Yes, it is bell-shaped enough. Beautiful. No, it is not bell-shaped enough. Okay, we like it's bell-shaped. Let's go ahead and calculate it as if it were perfectly bell-shaped. And this is one of those questions. It's great. You can pick either way. We'll come back and look at it a second way, not assuming it's bell-shaped. But I love the fact that you guys said it was. So here is one fairly formal definition of an outlier. And you guys have already said it. Oh, let me turn this off. Switch the camera. Too many electrical gadgets.